Hello everyone, and welcome back to our channel. We're thrilled to have you here with us at SJEC Engineering and Construction. Today, we are going to explore a fundamental process in steel fabrication known as welding. Welding is a crucial engineering process that helps us create strong, durable structures by joining metal pieces together. This diagram shows parts of a weld joint after joining two plates: weld face indicating quality, toe as a stress point, heat affected zone affecting mechanical properties, fusion line ensuring a strong bond, and root for integrity. Each part is vital for the weld strength, durability, and success. Let's dive into why welding is so important and how we at SJEC use metal inert gas known as MIG welding and flux shielded arc, which is known as stick welding, to ensure the highest quality in our projects. Moreover, welding is crucial in steel fabrication because it provides the strength to hold large structures together, making it ideal for everything from skyscrapers to industrial tanks. Without proper welding, these structures couldn't withstand daily stresses and strains. With over 2 decades of experience as a leading steel structural fabricator, we take pride in our quality assurance and the satisfaction of our customers and clients. Today, we are here to provide an in-depth explanation of the different types of welding and offer a basic tutorial on welding techniques. First, let's dive into the different kinds of welding methods. Shielded metal arc welding, SMAW, commonly known as stick welding, is one of the most traditional welding methods in steel fabrication. It uses a consumable electrode coated in flux to lay the weld. It is ideal for welding iron and steel, particularly in construction and industrial fabrication. Moving on, the second type of welding is gas metal arc welding, GMAW. Also known as MIG welding, MIG uses a continuous wire feed as the electrode and an inert gas to shield the weld from contaminants. This method is popular for its speed and ease of use, making it suitable for welding aluminum and non-ferrous materials. The third type of welding type is gas tungsten arc welding, GTAW, commonly referred to as TIG welding, which uses a non-consumable tungsten electrode to produce the weld. This method provides high-quality and precise welds, ideal for thin materials and critical welds in aerospace and automotive industries. Apart from that, flux cored arc welding, FCAW, is the fourth type of welding, which is similar to MIG welding. Flux cored arc welding uses a continuous wire feed but with a flux core that provides shielding. It is well suited for outdoor welding and thicker materials due to its high deposition rate. The fifth and last type of welding is submerged arc welding, SAW. SAW involves the formation of an arc between a continuously fed electrode and the workpiece. The weld area is submerged under a blanket of granular flux, which protects it from atmospheric contamination. This method is efficient for welding large structures like storage tanks and pressure vessels. At SJEC, we prioritize quality in welding and more. We primarily use 2 types of welding techniques, MIG welding and stick welding. Both methods are efficient, reliable, and ensure our steel structures meet the highest standards. Moreover, at SJEC, we adhere to stringent welding procedure specifications, WPS, to ensure consistency, quality control, and regulatory compliance in all our welding operations. We conduct rigorous welding qualification tests, WQT, to verify our welders' skills and ensure they meet the highest standards of safety and quality. Additionally, we employ non-destructive testing, NDT, methods to inspect our welds for internal and surface defects without causing damage. These practices, WPS for standardized procedures, WQT for skill verification, and NDT for thorough inspection, are integral to maintaining the highest standards in our projects, ensuring safety, reliability, and compliance with industry requirements. We use E6013 for thin sheets with easy control and E7018 for thicker materials, providing high strength and reducing hydrogen cracking in stick welding. For welding stainless steel to steel, we use E308L electrodes for excellent corrosion resistance. Additionally, we use MIG solid wire in different thicknesses, such as 0.8 mm and 1.2 mm gauges, depending on project requirements. These choices ensure our welding meets the highest standards, providing safe, high-quality, and durable solutions. This essential tutorial covers key welding techniques, safety measures, and best practices to help you achieve perfect welds every time. Start your journey to mastering welding with this concise guide. Starting with basic fundamentals of MIG welding involves feeding a continuous wire electrode through a welding gun while shielding the weld with a gas to prevent contamination. It produces a clean, high-quality weld with minimal spatter, making it perfect for precision work. On the other hand, stick welding uses a consumable electrode coated in flux, which melts and fuses with the base metal to form a strong weld. This method is versatile and effective for welding thicker materials and in various positions. Let's talk about safety gears and their importance during all types of welding. Starting with face shields protect against intense light, sparks, and harmful rays, while fire retardant jackets shield the body from sparks and heat, reducing burn risks. Next, welding aprons protect the front of the body from hot metal and sparks. Welding gloves insulate hands from heat, sparks, and sharp edges, ensuring a secure grip. Following with safety boots with steel toes and heat-resistant soles protect feet from falling objects and hot debris. Lastly, anti-dust masks protect the respiratory system from hazardous fumes, smoke, and particulate matter generated during welding. All these safety gears listed before are essential as they serve as personal protective equipment not only for the welding process but also for various other operations. Next we are going to show MIG welding equipment setup and basics demonstration from our certified welders. Let's learn how to set up equipment for MIG welding. This is a basic equipment setup fundamental diagram of MIG welding to learn and understand in depth. Start by cleaning the metal surface of the workpiece to remove any rust or contaminants. Next, attach the work clamp to the workpiece, ensuring a solid connection, and then plug the welding machine into an appropriate power source and turn on the machine when fully done setup. After that, install the wire reel by placing it onto the spindle, securing it, and feeding the wire through the rollers and into the MIG gun. Additionally, attach the gas hose to the shielding gas source and the welding machine, then open the gas valve and set the flow rate. Mainly, we will use a mix of argon and CO2 for MIG welding. Furthermore, thoroughly check all connections to ensure proper alignment and secure connectivity for smooth and safe operation. Then, adjust the voltage and wire feed speed on the welding machine according to the material's thickness and type. This involves selecting the appropriate voltage level to ensure proper penetration of the weld and adjusting the wire feed speed to control the amount of filler material being deposited. Proper adjustments are crucial for achieving a strong, high-quality weld and avoiding issues such as spatter, porosity, or insufficient fusion. Finally, check all connections, test gas flow, and begin welding. We will be showing basic tutorial of MIG welding by weld 2 plate of steel. Clean the metal surfaces to remove rust, paint, or oil for a strong bond. Start with a tack weld to hold the pieces together. Tack welding secures temporary joints before final welding begins. Continue to tack weld both sides. Hold the gun at a 10 to 15 degree angle from vertical and maintain a steady hand. Once the pieces are tacked, continue welding along the joint. Move the torch smoothly and consistently, maintaining the correct distance between the nozzle and the workpiece. Use a steady, back and forth or circular motion to ensure proper penetration and bead formation. Once done welding, use a chipping hammer to remove slag, which is the black, crusty substance left on the weld. Then, brush the area with a power wire brush to clean any remaining debris and ensure a smooth, clean surface. A good weld will have a uniform appearance and be free of any visible flaws. Inspect weld for defects, cracks, porosity, clean with wire brush. Turn the metal plate to continue to weld the opposite side. Repeat the procedure on the other side for proper welding joint. Follow the same procedure again to weld the another side of the metal plate. Finally, inspect the weld for defects such as cracks and porosity. Then clean the welding area with a wire brush to ensure a smooth, strong finish. Make any necessary adjustments or touch-ups to address any imperfections. Once satisfied with the weld quality, turn off the welding machine, close the shielding gas valve, and properly store the MIG gun and equipment. Ensure the work area is clean and safe, ready for the following welding task. Now, let's talk about stick welding. Learn the precise equipment settings for stick welding and follow a step-by-step demonstration of basic stick welding techniques to ensure optimal performance and weld quality. Following with the step-by-step equipment setup for stick welding. This diagram shows the stick welding setup. The SMAW machine converts power for welding. It connects via lead cables to the electrode holder and workpiece clamp. The electrode fuses base metals on a stable welding table. The ground clamp ensures a complete electrical circuit, enabling effective welding. To set up the SMAW machine, plug it into an electrical power source. Moreover, check the amperage settings to ensure they match the requirements for the electrode and workpiece. Secure the ground clamp to the workpiece to complete the electrical circuit, and finally, connect the workpiece lead cable from the ground clamp to the SMAW machine. Let's start our basic tutorial for stick welding by welding two pieces of metal plate together. Starting with a tack weld involves holding the pieces together with small, temporary welds to maintain alignment. Clean the surfaces, set up the welding machine with the correct amperage and electrode, and ensure proper polarity. Tack welding temporarily holds parts for final welding to be done. After completing the tack welds, thoroughly clean off any slag or debris using a wire brush or grinder. This step is crucial as it ensures a clean and smooth surface for the main welding procedure, which helps in achieving strong, high-quality welds. Proper cleaning prevents contamination and improves the weld's overall integrity and appearance. Hold the electrode at a 10 to 15 degree angle from vertical in the direction of travel. With the tack welds cleaned, position the electrode along the joint, maintaining a 1/8 inch, 3 mm, arc length. Adjust your travel speed for even heat distribution and proper penetration. This technique ensures a strong, uniform, and aesthetically pleasing weld. Strike the electrode against the workpiece like a match to initiate the arc. Continue welding along the joint you started. Move the electrode smoothly and steadily, keeping it about 1/8 inch, 3 mm, from the metal. Listen for a steady buzz, which means your weld is good. If you hear crackling or sputtering, adjust your technique or settings. Maintain even movement and control to create a uniform weld bead. Watch the weld puddle to keep it molten and fluid, but not too large. Consistent movement and technique will result in a strong, high-quality weld that is durable and looks good. Maintain consistent speed, steady motion, drag or weave as needed for joint. Move the electrode smoothly and consistently, maintaining the correct arc length of about 1/8 inch. Adjust your travel speed to prevent overheating, and use a slight weave pattern for better weld coverage. Consistent movement and technique will result in a strong, high-quality weld that is durable and looks good. Monitor the weld puddle to ensure proper bead formation and penetration. Cleaning slag or debris is time-consuming and requires additional effort. If not done correctly, it can damage the weld or underlying material. It also generates dust and noise, contributing to an uncomfortable working environment. Chip off the slag with a chipping hammer and clean with a wire brush. Clean off any slag or debris with a wire brush and chipping hammer to smooth the surface after welding. This ensures a clean finish and prepares the weld for further processing or inspection. Inspect the weld for defects such as cracks, porosity, or lack of fusion. Change the metal plate position to weld the other side, ensuring even strength distribution and reducing stress concentration. Welding both sides prevents warping and enhances structural integrity, durability, and load-bearing capacity. This process results in a more reliable and long-lasting weld, crucial for high-quality and safe metal fabrication projects. Repeat the procedure on the other side for proper welding joint. Then continue welding the other side in the same manner as previously, ensuring you maintain consistent technique and settings for optimal results. Use the same electrode type and amperage, and keep the arc length at about 1/8 inch, 3 mm, from the metal surface. This arc length is crucial for creating a strong, penetrating weld. Move the electrode smoothly and steadily, listening for that steady buzz which indicates a good weld. A consistent buzz signifies stable arc performance, essential for a uniform weld bead. If you hear any crackling or sputtering, adjust your technique or settings, as these sounds can indicate issues with arc stability or contamination. As you proceed, pay close attention to the weld puddle, ensuring it stays molten and fluid without becoming too large. The size and consistency of the weld puddle are critical for ensuring proper fusion between the metals. Adjust your travel speed to achieve even heat distribution and proper penetration. A steady travel speed prevents overheating and ensures that the weld bead is neither too thick nor too thin, maintaining structural integrity. After completing the weld, clean any slag or debris with a wire brush and chipping hammer to maintain a smooth, even surface. Removing slag prevents inclusions and ensures the weld is visually and structurally sound. This process not only improves the appearance of the weld but also its quality and longevity. By following these steps meticulously, you achieve professional, reliable results, essential for any successful metal fabrication project. That's all from us today. Thank you for watching this video in its entirety. Learn more about engineering and construction in our upcoming videos.